probability tree diagrams. So throughout this video, we will be talking about dependent events. Now, the following situation can be represented by a tree diagram. Now, let me quickly give you a scenario. Kante has 10 colored cubes in a bag. 3 of the cubes are red and 7 are blue. He removes a cube at random from the bag and notes the color but does not replace it. He then chooses a second cube at random, then record the information in a tree diagram. Now, in order to record this information in a tree diagram, so the tree is going to have 2 arms, that is the arm for red and the arm for blue. Now, let's see the first choice. So this one is for red and this one is for what? For blue. Now, for red, now they say that 3 of the cubes are what? Are red. That is 3 out of 10. That's why we're having 3 over 10 here. Then for blue, 7 are blue. So we're having 7 over 10 here. That is for what? For blue. Now, under the first arm now, we're still going to have red and blue again. So this is the second choice. So for the second choice, this arm is for red and this arm is for blue. But it now removes a cube at random from the bag and notes the color but does not replace it. So out of the 3 red here now, 1 has been taken and does not replace. Is that okay? So since this one is without replacement, out of these 3, 1 has been taken. So these 3 will reduce to what? To 2, and 10 will reduce to what? To 9. Exactly. But for blue, under this arm now, so you know this one now, under red, we said that 1 has been taken from the red, right? So that the total of the red is what? Is 2 now. But for blue here now, nothing has been taken there. So we're still going to have what? 7. But the total has already been affected. Is that okay? Because 1 has been taken here. So the total here will be 9. That's why we're having 7 over 9 for blue. Exactly. Now, under blue here now, 7 has been taken here. So if you, this arm is for red and the second arm is for what? Is for blue. Now, because out of 7 here, 1 has been taken. So that's why we're having the total to be 6 here. Then out of 10, 1 has been taken without replacements. So the total here is what? 9. Now the total here is also 9. But from the blue here now, we have not taken any red. That's why the total for red is still what? 3 over 9. Is that clear? Now, so now to calculate the probability for red now. So probability for red, just take this number, multiply by this fraction, multiply by this fraction, and this is what you are seeing here. Exactly, that is red. So the probability for red and blue now. So red, blue, just pick 3 over 10 multiplied by 7 over 9. That is what you are seeing here. That's 21 over 90. So the probability for blue and red is equal to what? Pick this fraction multiplied by this fraction. So now I will give you 21 over 90. Then the probability for blue and blue is equal to what? Pick this fraction multiplied by this fraction. That's 7 over 10 multiplied by 6 over 9. So that is what? How to represent the information like this. That is dependent information like this on a what? In a tree diagram. Now let's now look at example here. So example 1 here. Mercy has 9 colored beads in a bag. 4 of the beads are black and the rest are green. So the total beads here is what? 9. Out of which 4 of the beads are what? Are black. And then the rest are what? Are green. So if you take away 4 from 9, the remainder is what? 5. That means the total for green is what? 5. It removes a bead at random from the bag and does not replace it. does not what replace it. So it then chooses a second bit to draw a tree diagram showing all possible outcomes. Then calculate the probability that Messi chooses two green bits, then number two, a black followed by a green bit. So in order to draw the uh, tree diagram, so for the first choice, we're going to have two arms. We have arm for black and then arm for green. So for the black now, so the total here is what? 4 over 9. This is 4 over 9. Then for green, if you take away 4 from 9, the remainder is what? 5. So the remainder is 5 over what? Over 9. That is for green. Now under this arm now, for the second choice, we are going to have black and green again. So for black here now, 1 has been taken here now, it will reduce to 3. So then the total out of 9, 1 has been taken, it will reduce to 8. But for black here, we have not taken anything from green. So the total for green will still be 5, but the total of everything has already been reduced to what? To 8. Now coming to the green arm here now, we have 5 over 9. Is that clear? So one has been taken from the green now. So for the green here, we are going to have 4 over 8 because 1 has been taken without replacement. Now for the black arm here now, we have not taken anything from this arm before, from the green. So the total for green will still be what? Be 4. But the total for everything is what? Is 8 because 1 has been taken here from the green. Is that clear? Now, so that is what? The tree diagram for this question. Now, we are now asked to what? To calculate the probability that Messi chooses two green bills. So the probability for two green bills now, so we are going to calculate green. For two green bills is what? Green and green. So for green and green, just pick this fraction, multiply by this fraction. So 5 over 9 multiplied by 4 over 8. So the answer is equal to what? 20 over 72. So that is the answer for what? Two green bits. Then the second one, a black followed by a green. So we now come to black arm here. This is the black, then followed by green. So pick this fraction, multiply by this fraction. That is 4 over 9 multiplied by 5 over 8. The answer is also equal to what? 20 over 72. And that is the answer for this first example. Now, let's look at another example. Lucky has a box of 30 chocolates. 18 are milk chocolate and the rest are dark chocolate. She takes a chocolate at random from the box and eats it. So she then chooses a second. So here now, there's no any information as regard to whether replace or not replace. So this one is also without replacement. Is that clear? So draw a tree diagram to show all the possible outcomes. So in order to draw the tree outcome, we're going to have the first pick and the what? Second pick. Now the total chocolate is what? 30, out of which 18 are what? Milk. So 18 out of 30, that is 18 over 30, that is for milk. Then the arm for dark is what? If you take away 18 from 30, the remainder is 12. So the remainder is what? The rest are what? Dark. That means 12 over 30 is for dark. Now for the second pick here now, we're still going to have milk and dark arm. Milk and what? Dark arm. Now for the milk here, now 1 has been taken here without replacement. So this one will reduce to 17 and this one will reduce to what? 29. But for the dark, we have not taken anything from dark here. The total will still be of dark will still maintain the what? 12 over the total, while the total here is equal to 29 because 1 has been taken from the total here. Then for the dark here now, so we have taken 1 out of the dark, right? So this one will reduce to 11 over 29. Then but for the milk now, we have not taken any milk from this arm. So the milk will still be what? 18 then over 29. That is the tree diagram to show the possible outcomes. Then calculate probability that Lucky chooses two milk chocolates. Two milk will be what? Milk and milk. So milk and milk, just pick this fraction, multiply by this fraction. So 18 over 30 multiplied by 17 over 29 is equal to 306 over 870. Now, the second one, a dark chocolate followed by a milk chocolate. So you need to come to dark here. So dark chocolate followed by what? By milk. Just pick this fraction, multiply by this fraction. So 12 over 30 multiplied by 18 over 29. So, and the answer is equal to 216 over what? 870. So, and that is the answer for the second example here. So, if the two examples are clear, so I would like you to do the two exercises that I have here. So, this is the first one, and this is the second one.